You've built with the Claude API. You've wired up tool calls at 2 in the morning, watched an agent loop spin one turn too many, and learned the hard way that the difference between a demo and a product is everything the tutorials skip. Here's the news: Anthropic now runs a proctored exam for exactly that knowledge, and of their 4 certifications, this is the one built for engineers. It's called the Claude Certified Developer Foundations level, and in the previous video I called it the strongest signal per dollar in the whole program. Here's why: it's the hands-on Builder Credential, identity verified and supervised, at a moment when every resume on the planet suddenly claims AI experience. A completion badge says you watched a course. This says you were tested alone under a proctor, on shipping real Claude applications, and passed. This video is the complete guide: who the exam targets, all 8 domains with their official weights, and fair warning, those weights hide the biggest study trap in the entire certification program. Then every domain taught properly with worked exam-style scenarios, the free study stack, a 4-week plan built around actually shipping something, an exam day itself. Follow it end to end and you'll walk in prepared. Let's build. Chapter 2: Who this exam is for. Anthropic's target profile is specific: AI engineers and software developers with 1 to 5 years of engineering experience and at least 6 months of real hands-on work with Claude or a comparable large language model system. Comfortable in Python or TypeScript, fluent with REST APIs and command line tools. As always in this program, that's recommended, not required. The credential is awarded on exam performance alone. 3 portraits of the actual candidate: a backend engineer who shipped a customer support assistant on the API, tool calls, structured outputs, retry logic and all. A full-stack developer who bolted Claude into an existing product and now owns its cost line. An AI engineer who builds agent workflows and has opinions, strong ones, about when an agent is the wrong answer. Different titles, same fingerprints on the same kinds of code. Those fingerprints are what the exam checks for. And let's set the biggest expectations straight immediately. This is not a prompting exam. Prompt and context engineering is one domain of 8 and a modest one. The paper is dominated by software questions, API mechanics, application design, integration patterns, cost management, security. If you can only prompt, you'll struggle. If you can engineer and you've genuinely used Claude's platform features, you're closer than you think. This video's job is closing the gap between those two. Chapter 3: The exam at a glance. 53 questions, 120 minutes. That's over 2 minutes per question, the most generous time budget of the 4 exams, and it's generous for a reason. Developer scenarios come with more to read, sometimes a chunk of behavior to reason about. Multiple choice and multiple response, with the answer count always stated. Scoring is the program's standard machine, a scaled score from 100 to 1000, passing at 720. Not a percentage, don't convert it in your head. Your report shows pass or fail, the scaled score and percent correct per domain, so even a miss hands you a map. The fee is $125 per attempt, proctored through Pearson VUE, online or at a test center, identity verified before the clock starts. The credential runs 12 months, renews free if you're on time via a lighter non-proctored assessment, and costs the full fee again if you let it lapse. Fail, and the retake ladder is 14, 30, then 90 days, 4 attempts per rolling year. Registration is the path we walked in the first video of this series. Claude Partner Network, then the Partner Academy, then Pearson VUE. And the standing rule of this whole series applies double here: download the current official exam guide before you book. Everything in this video is built against version 1. The program is young, and the guide is the source of truth. Chapter 4: The blueprint and the trap inside it. 8 domains, and this guide goes further than any other in the program. It weights 25 individual subskills. That granularity is a gift because it tells you almost embarrassingly precisely where the points are. Let's read it like engineers. Heaviest first, applications and integration, 33.1%, one domain, a third of the exam. Then model selection and optimization at 16.8. Agents and workflows 14.7, prompt and context engineering 11, tools and MCPs 10.6. Security and safety 8.1, and then 2 tiny ones, Claude Code at 3.1% and Eval, testing and debugging at 2.6. Now the trap, and it's a double trap. Trap 1, because Claude is famous for prompting. Candidates overstudy the 11% prompting domain and walk in weak on the 50% that actually decides the exam. Applications plus model selection, together half the paper, full of batch versus real-time trade-offs, configuration management, and caching economics. Trap 2, Claude Code. Developers love it, use it daily, and assume it's central. On this exam, it's 3.1%, a single subskill. It's the architect exam that gives Claude Code a heavyweight domain, not this one. Study by the blueprint's numbers, not by your affection for the tools. One housekeeping note: the guide numbers the domains in its own order, agents first, and will teach in that order so the domain numbers on screen always match the official guide. But your study hours should follow the weights, and the plan at the end of this video does exactly that. 8 domains, one by one. Here we go. Chapter 5, How Developer Questions Think. If you watched the associate video, you know the exam family's question skeleton: situation, symptom, ask, and you know the 3 distractor species: the extremist, the symptom treater, and the true but irrelevant. All 3 prowl this paper too. But the developer exam adds a 4th species you need on site: the overbuild. The overbuild is the answer that solves the problem with more machinery than the problem deserves. Agent misrouting tools. The overbuild says add a routing model or fine-tune. The scoring answer improves the tool descriptions, costs climbing on repeated context. The overbuild re-architects the whole pipeline. The scoring answer turns on caching. Engineers are especially vulnerable to this species because building more feels like competence. On this exam, the elegant minimal fix wins consistently, because in production the elegant minimal fix is what a senior engineer actually ships. Keep the reading habits from the associate playbook. Last sentence twice, trust the stated answer count, and when 2 answers both look right, hunt the planted tiebreaker. Here it's usually a constraint, latency, budget, data sensitivity, or scale. Loaded, good, domain 1. One drill before we dive, because the species matter more here than on any other paper. As each domain's exam lens comes up in this video, pause when the options appear, pick your answer, and name the species of at least 2 distractors before the reveal. It sounds like a game. It's actually the exam's core skill, because on the real paper nobody labels the wrong answers for you. By the 8th domain, you'll be labeling them yourself faster than you can read them, and that reflex, not memorized facts, is what a comfortable pass feels like from the inside. Chapter 6, Domain 1, Agents and Workflows. 14.7%, the 3rd biggest slice, split across agent architecture, agent construction with Claude, and agent patterns and frameworks. The single most important idea in this domain is a distinction: workflows versus agents. A workflow is a system where your code decides the path, call the model, take the output, call it again, in a structure you designed. Prompt chaining, one step feeding the next. Routing, where a cheap first call classifies the request and sends it down the right branch. Parallelization, fan out, then aggregate. Orchestrator and workers, one model planning, others executing. Evaluator and optimizer, one model generating, another critiquing in a loop. An agent is different in kind. The model decides the path, calling tools in a loop, observing results, choosing what to do next until it decides it's done. And the exam's favorite question in this domain is not, can you build an agent? It's, should you? The scoring instinct: use the simplest structure that solves the task. Predictable steps, known sequence, workflow every time, cheaper, faster, debuggable, testable. Open-ended task where the path genuinely can't be scripted. Research, multi-step tool use against unpredictable state. That's what agents are for, and they buy that flexibility with cost, latency, and a harder testing story. Reaching for an agent when a 3-step chain would do is the overbuild species in its natural habitat. On construction, know the agent loop cold. The model returns a signal that it wants a tool. Your code runs the tool, sends the result back, and the loop continues until the model signals it's finished, plus the guardrails production demands, a cap on iterations, timeouts, and a defined way to fail. If a scenario shows an agent spinning forever or burning budget, look for the answer about loop limits and termination conditions, not the one adding a second agent to supervise the first. The exam lens, a ticket triage system: classify the ticket, look up the customer, draft a reply, same 3 steps, every ticket in order. The team proposes an autonomous agent with a dozen tools. Best guidance. The scoring answer is the workflow, a routed chain because the path is fixed and an agent adds cost and unpredictability for nothing. The distractors, the agent because it's more capable, that's the overbuild, refusing automation entirely, the extremist. And a true fact about agent frameworks that answers nothing. You can hear it now, can't you? That's the point. Chapter 7, Domain 2, Applications and Integration, 33.1%. A third of the exam, 1 domain, 6 subskills, and the biggest of those subskills, Claude application design, is alone worth more than the entire Claude Code and debugging domains combined. If you optimize one chapter of this video, optimize this one. Start with API mechanics because everything sits on it. The message's API is stateless. Every request carries the full conversation, an array of user and assistant terms, with the system prompt as its own parameter, not a message. No memory happens unless your application sends the history. Know your request anatomy, model, system, messages, max tokens, temperature. Know what comes back, the content, the usage counts you'll be billed on, and the stop reason telling you why generation ended, finished naturally, hit the token cap once a tool, or hit one of your stop sequences. Scenario questions love a truncated response whose cause is simply a low token cap. Read the stop reason, don't guess. Then the platform features that turn one API into an application toolkit. Streaming, tokens arriving as they're generated for anything a human watches. Nobody waits 30 seconds staring at a spinner. Vision, images in the message content alongside text. Prompt caching, mark the big stable prefix of your prompt, the system instructions, the reference documents, and repeated calls read it back at a fraction of the price instead of paying full rate every time. And the batches API, asynchronous processing for jobs that can wait. Thousands of requests submitted together, results within a day at roughly half the cost. The exam's favorite pairing, real-time plus caching for the chat experience, batch for the nightly pipeline. Choose by latency requirement and the cost follows. A word on the toolkit itself because integration questions assume it. The official SDKs, Python and TypeScript first among them, handle the plumbing, authentication, retries on transient errors, streaming helpers, type definitions. The exam-shaped judgment is boring and correct. Use the official SDK rather than hand-rolling HTTP calls, because the plumbing you didn't write is the plumbing you don't debug. An interface choice is a design decision with a latency badge. A chat interface needs streaming and session state your application maintains. An API endpoint wrapping Claude needs its own timeout and error contract, and a background job needs none of that but should probably be a batch. When a scenario describes where Claude sits in a system, it's really asking which of those contracts applies. Application design is the subskill with the biggest single weight, and it's about requirements before code, the associate exams lesson wearing an engineer's badge. What interface, chat, API endpoint, background job, what latency budget? What failure behavior because the model will sometimes return something unusable, and a production design says what happens then. Validation, retries with backoff, a fallback path, a human escalation. Software engineering foundations backs this with the boring virtues, idempotency, logging, separation of the prompt layer from business logic. And configuration management, 4% all by itself, which is the guide quietly telling you it shows up. API keys live in environment variables or a secrets manager, never in code, never in the client. Prompts are versioned artifacts, changed deliberately, tested before rollout, because a prompt edit is a deployment. Model choice is configuration too, pinned and intentional, so an upgrade is a decision with a test pass, not a surprise. The exam lens, a nightly job summarizes thousands of documents with the same system prompt, costs are climbing and nobody reads the results before morning. Choose 2 optimizations, the scoring pair, move it to the batches API and cache the shared prompt prefix. The distractors switch everything to the biggest model, irrelevant to cost, backwards actually, and rewrite the summaries to be shorter, a symptom treater that saves pennies while the architecture wastes dollars. Latency requirement first, then the machinery. That instinct alone is worth several questions. One more lens because a third of the exam earns 2. An application parses Claude's JSON output directly into its database, and once a day the model wraps the JSON in a polite sentence, crashing the pipeline. Best fix. The scoring answer: constrain the output format, prefilling or structured output, and validate before writing, retry on parse failure. The distractors: a prompt that says only output JSON in capital letters, symptom treater, it helps until it doesn't. Manually reviewing every record, extremist, goodbye throughput, and switching models, the true but irrelevant, with a price tag. Trust the schema in code, never in hope. Chapter 8, Domain 3, Claude Code, 3.1%, and yes, that number is correct. The agentic coding tool that's probably open in your terminal right now is a single subskill on this exam operation. Can you use it properly? The architect exam is where Claude Code gets a heavyweight domain of its own. Here, it's a cameo. So here's the cameo-sized version. Claude Code is Claude operating in your development environment, reading the code base, editing files, running commands in an agentic loop under your supervision. The piece is worth knowing: the project memory file where standing instructions live so the agent knows your conventions without being retold, / commands for reusable operations, and permission behavior it asks before consequential actions, and that's a feature, not friction, tightened or relaxed deliberately. The exam-shaped instinct, standing knowledge belongs in the memory file, not repeated in every session, and autonomy is granted in proportion to trust and reversibility. That's the whole 3.1%. Don't let your affection for the tool buy it more study hours than the blueprint pays for. Chapter 9, Domain 4, Eval, Testing and Debugging. 2.6%, the smallest domain, focused on debugging and error handling, and it's nearly free points for anyone who's operated a real integration. 2 families of failure. API errors: you can be rate limited, hitting request or token limits, answered by backing off exponentially and retrying, not hammering, and the service can be briefly overloaded, same medicine. Handle both in code because production traffic will find them. The second family is behavioral: the call succeeded and the output is wrong. The debugging instinct the exam rewards is evidence first. Read the stop reason, check the usage numbers, log the full request and response, reproduce with the same inputs. Truncated output. Almost always the token cap, check before touching the prompt. And the eval mindset in one sentence: a golden set of test cases run against every prompt or model change, so quality is measured, not vibed. One sentence, a couple of questions, free points. The quick lens: a batch pipeline's outputs are cut off mid-sentence on long documents, first move. Read the stop reason, it says the token cap was hit, and the fix is raising the output limit for those documents, not rewriting the prompt, not switching models, and not the overbuild's cameo here, adding a second pass that stitches truncated outputs together. Evidence first, then the smallest fix. That instinct is this whole domain. Chapter 10, Domain 5, Model Selection and Optimization. 16.8%, the second biggest domain, and notice where its weight actually sits. LLM fundamentals and technical fundamentals together dwarf the model picking subskill. The exam wants to know you understand what these systems are, not just which tier to click. The fundamentals that show up: tokens, the model reads and writes in tokens, a few characters each. Your build per token, input and output priced differently, and the context window, the model's working memory, is measured in them. Temperature, the randomness dial, low for deterministic extraction in code, higher for creative variety. The classic scenario is inconsistent outputs from a data pipeline, and the answer is turn the temperature down, not write a sterner prompt. And the context window is finite. Long conversations and big documents eventually need summarizing, chunking, or externalizing knowledge. Sound familiar? The associate video's context hatches, now with an engineering budget attached. Technical fundamentals is the domain's biggest subskill, and it's the system's view. Latency versus throughput. A chat interface cares how fast the first token arrives. A pipeline cares how many documents per hour. Streaming changes perceived latency, batch changes cost, neither changes the model's intelligence. Know the shape of the trade space. Bigger context and bigger outputs cost time and money. Quality ceilings differ by tier, and every requirement in a scenario, real-time, overnight, high-volume, budget cap, maps to one corner of that space. The exam hands you requirements and watches whether you can find the corner. Tier selection is the trade triangle, the fast, cheap tier for high-volume, simple work, the workhorse for everyday builds, the top tier when reasoning quality outranks everything. The developer twist is that the exam prices the decision, which tier for a classifier handling 1 million requests a day. The fast one, obviously, but the scoring answer often adds the engineering move and route the hard cases up a tier. Cascading, cheap first, escalate on failure, beats paying premium for every request. And cost and token management as its own discipline, the levers in rough order of power, caching for repeated context, a massive saving on the prefix, batch for anything asynchronous about half price, right-sizing the model per task. Capping output length because output tokens cost more than input, trimming the fat from prompts. A scenario hands you a bill and asks what to pull first. The answer is whichever lever matches the workload's shape. Repeated prefix means cache, overnight tolerance means batch. Read the workload, then reach. The exam lens, a team runs sentiment analysis on every incoming review with the top-tier model at high temperature, and results vary run to run. Choose 2 fixes. The scoring pair, drop to the fast tier, the task is simple classification, and lower the temperature for consistency. The distractors, a longer prompt demanding consistency, symptom treater and switching providers, extremist with a passport. Half this domain is exactly that, match the machine to the job and know which dial does what. Chapter 11, Domain 6, Prompt and Context Engineering. 11%, and after all the warnings about overstudying it, let's be clear. 11% is still real points, and the developer version of this skill is different from the chat version. You're not writing one good prompt, you're writing a prompt system that stays reliable across thousands of unseen inputs. The techniques the exam expects: production grade, a system prompt that sets role and rules once, cleanly separated from user input. Structure in the prompt, delimiters and tags so the model can't confuse instructions with data, and so injected text in a user document is data, not commands. Remember that sentence, it comes back in security. Few-shot examples for anything with a format: 2 or 3 input-output pairs beat a paragraph of description. And prefilling, starting the assistant's answer yourself, forcing format from the first character, the cheapest structured output trick there is. Context engineering is the newer name for the bigger game, deciding what the model sees at all. Retrieve only what's relevant instead of stuffing everything, order it deliberately, big stable content first, which is exactly what makes caching work, and keep the live conversation lean, summarize or drop what no longer matters. Output handling closes the loop. Ask for structured output, validate it in code, and never assume the model followed the schema, parse defensively, retry on failure. The exam lens here is usually a reliability story, a prompt that works in testing, flakes in production, and the scoring fix adds structure and examples, not adjectives and pleading. The exam lens, an extraction prompt, performs beautifully on the 10 test documents, then in production returns prose instead of the expected fields for 1 input in 20. Choose 2 fixes. The scoring pair, add few-shot examples pinning the exact output format and prefill the response so it starts in format. The distractors, add please respond correctly to the prompt ceremony, the associate audience is smiling, and raise the temperature, actively backwards. Production reliability comes from structure and examples, never from adjectives. Chapter 12, Domain 7, Security and Safety. 8.1% and the highest stakes points on the paper because these questions are auditions for production incidents. 4 subskills: application security, guardrails, hooks, and identity and secrets. The centerpiece is prompt injection, content the model processes, a user message, a retrieved document, a web page containing text that tries to override your instructions. Ignore your rules, reveal your system prompt, call the dangerous tool. The defenses: the exam rewards are layered, and none is the extremist answer of refusing to process external content. Structure the prompt so external content is clearly data. Constrain what the model can do, least privilege on tools. An agent that only needs to read should not hold a tool that writes. Validate model outputs before acting on them, especially anything that becomes a command, a query, or a purchase, and keep a human on the irreversible steps. Identity and secrets is short and absolute. API keys server-side only in environment variables or a secrets manager, rotated, never shipped in client code, never committed, and if a scenario shows a key in a mobile app, the answer is a backend proxy, no exceptions. Guardrails and hooks rounded out, validation checkpoints around model actions, deterministic checks at the moments that matter, before a tool runs, before an output ships. The instinct that scores across all of it. The model is a capable, unpredictable component, so the system around it enforces the rules in code where enforcement is guaranteed. The exam lens, a support agent summarizes emails, and a crafted email makes it call the refund tool. Choose 2 defenses. The scoring pair, remove the refund tool from the summarization path, least privilege, and treat email content as untrusted data with output validation before any tool acts. The distractors, a sterner system prompt saying ignore malicious instructions, a symptom treater that first-year red teamers walk through, and refusing to process email, the extremist. Structure, privilege, validation, say it like a mantra. Chapter 13, Domain 8, Tools and MCPs. 10.6%, Tool implementation, MCP server development, and agentic customization. This is where your code becomes Claude's hands, and the craft is mostly in something that looks trivial and isn't, descriptions. A tool is a schema you hand the model, a name, a description, type parameters. The model chooses tools by reading them, which means the description is an interface for a reader, not documentation for a human. Say what the tool does, when to use it, and when not to. Name parameters unambiguously. The exam's favorite failure, you saw it in the series opener, is the misrouted tool call, and the scoring fix is better descriptions and clearer parameter definitions before any bigger machinery. Then the mechanics, the model signals which tool and with what arguments your code executes, sends back the result, and the model continues your code, your responsibility, which is why validation and least privilege from the security domain live here too. MCP, the Model Context Protocol, is the standardization layer. Instead of wiring custom integrations per application, a server exposes tools and resources over a standard protocol, and any MCP-speaking client can use them. The exam-shaped judgment, build an MCP server when a capability should be shared and reused across applications and teams. Keep a plain and process tool when it's specific to one app. An agentic customization is the umbrella for tailoring agent behavior. The tool sets you expose, the standing instructions, the hooks, chosen deliberately per use case, rather than shipping one agent with everything enabled. Smallest capable surface, described precisely, that's the whole domain in a sentence. The exam lens, 3 teams each hand-wired the same internal customer lookup integration into their Claude apps with 3 different bugs. Best move, the scoring answer, 1 MCP server for customer lookup, shared by all 3. The distractors, copy the least buggy version around, symptom treater. Have each team keep its own for independence, a true-sounding principle that answers nothing here, and build an agent to manage the integrations, the overbuild taking its bow. 8 domains down, now let's get you ready. Chapter 14, 5 ways to fail this exam, collected from how developers actually prepare so you can skip each one. Mistake 1, studying by affection instead of by weight. You love Claude Code so it gets a weekend, it's worth 3.1%. You find configuration management boring, it's worth more than Claude Code and debugging combined. The blueprint is a price list, spent accordingly. Mistake 2, overstudying prompting. 11%, we've covered it, and yet it remains the most seductive trap on the paper. Mistake 3, agent everything brain. If your default answer to every scenario is an autonomous agent, the overbuild distractor will feed on you all afternoon. The exam consistently rewards the simplest sufficient structure, and so does production. Mistake 4, preparing without an API key. This paper is written from the builder's chair. Candidates who only read about caching, stop reasons, and tool schemas reliably lose points to candidates who watch them happen in a terminal. The 4-week plan exists precisely so this isn't you. And mistake 5, dumps. The sites selling real exam questions are selling a rules violation stapled to wrong answers, and this exam scenarios punish memorization anyway. They test whether you can reason about a system you've never seen. The honest path is genuinely cheaper, a free blueprint, free documentation, free courses, one small project and a plan, which brings us to exactly that. Chapter 15, Your Free Study Stack. Same philosophy as the whole series. The fee is the only mandatory cost. 4 pieces. 1. The official exam guide, all 25 weighted subskills, your syllabus, and at the end, your checklist. 2. The official documentation, and for this exam it outranks any course, the API reference, the tool use guide, the agent guidance Anthropic publishes for engineers. The exam is built from the same well. 3. Anthropic Academy's developer courses, free, self-paced, covering the API and building with Claude. And 4. The one that matters most on a hands-on exam, a working project, an API key, a Scratch repository, and code you actually ran. Paid question banks exist and address rehearsal has value, but nothing behind a paywall is required, and the dumps promising real questions remain what they were in the associate video, against the rules and reliably wrong. One practical note on the documentation layer: read it with the blueprint open, and let the sub-skill names steer you. Requirements, lifecycle, configuration management, those dry phrases are section headings in disguise, and every one of them is worth more than another prompting tutorial. Chapter 16, The 4-Week Build Plan. 5 to 6 focused hours a week, and the organizing idea is different from the associate plan, because this exam tests building. You're going to ship one small thing and let it drag you through the blueprint. The thing, a little support assistant. An API integration with 2 tools, a lookup and an action, a system prompt and a cost budget. Trivial in scope, complete in structure, and it touches every heavyweight domain. If you're newer to the API, stretch the same plan across 6 weeks. The sequence is the point, not the calendar. Week 1, Foundations and the API. Read the exam guide, rate yourself on all 8 domains, set up the key and the repo. Then build the plain conversation loop, messages, system prompt, streaming, and deliberately break it. Hit the token cap and read the stop reason, trip the rate limit and write the backoff. That's domains 2 and 4 earning their keep on day 3. Week 2, the heavyweights. Add the 2 tools, watch the model, choose them, then sabotage your own tool descriptions and watch it misroute. No exam question will ever confuse you about descriptions again. Add caching to the system prefix and check the usage numbers before and after. Price your assistant at 3 tiers and pick deliberately. That's a third of the exam running on your laptop. Week 3, the judgment domains. Convert one flow into a routed workflow and argue out loud why it shouldn't be an autonomous agent. Then attack your assistant. Paste an injection into a fake customer message and fix the design, structure, least privilege, output validation. Skim Claude Code's essentials for its 3.1%. One honest session is plenty. Week 4, rehearsal. Reread the guide as a checklist. Every subskill, can I do this in code? Practice questions under time pressure if you have them. Weakest domain gets the final hours, and book the exam while the project is fresh. Because for this paper, your recent commits are the best flashcards that exist. Chapter 17, Exam Day and the Road to Architect. Logistics are the series standard. Pearson VUE system check on the actual machine the day before. Quiet room, clear desk, identification ready, workspace photos, no notes, no second monitor. And if your home setup is fragile, a test center makes it someone else's problem. In the room, 53 questions, 120 minutes, well over 2 minutes each, so the clock is your ally. Read the last sentence twice. Developer scenarios especially bury the ask under context. Trust the stated answer count. Name the species as you eliminate: extremist, symptom treater, true but irrelevant, and this paper's specialty, the overbuild. When 2 answers survive, find the planted constraint, the latency budget, the request volume, the data's trust level. Flag and move, a complete first pass beats a perfect half. Afterwards, the outcomes you already know. Pass, and the badge lands with a 12-month clock and a free on-time renewal. Calendar it. Miss, and the domain report plus the 14-day window turn it into a scheduled second attempt. 4 tries a year means it's a delay, not a verdict. Either way, you'll know your engineering profile against the sharpest blueprint in the program, and that knowledge outlives the exam. That's the complete path, the builder's credential, all 8 domains, the trap in the weights, the build plan, and the room. Everything here comes from the official exam guide and public documentation, independently made, no affiliation, no guarantees except the honest one. Master this blueprint and you belong in that room. The description has the dated study checklist, free as always. Next in the series, Architect Foundations, the scenario-based exam, all 6 scenarios included, where the questions stop asking how and start asking why. If this guide moved you closer to certified, a like helps the next builder find it, and subscribing means the Architect Deep Dive lands the moment it's ready. We're building AI up from the ground, one blueprint at a time. I'll see you in the next one.